Hello there. This is it. A couple of minutes later than expected, but the last presentation of Devoxx 2016. Thank you very much for selecting me. I'm honored. I hope I will not disappoint. This is my first time speaking at Devoxx, so yeah, I'm a little bit nervous. My name is Arne. I work for a company called Foreach. We specialize in building custom web applications with different technologies. And actually we're Antwerp based, where our office is only like a couple kilometers from here, so this is really a home game for me. This talk will be about a framework we've open sourced that helps us in modularizing our Spring-based applications. So I really want to make this a hands-on demo as soon as possible, but first I'd like to give a little bit of context, and I have to explain some things as well. So let's go back to the starting point for us what led us to actually building the framework that we needed. We've been, as I said, building larger web projects. They used to be called just, large projects. Nowadays they have a much cooler name called monoliths, which makes it sound very positive, right? But what we understand as a larger project would be like one consisting out of like a couple of tens of Maven modules, right? So in IntelliJ you would also have like several modules. This could be a CMS, this could be a public-facing website, but often, in our case, it also means there's like one big base project that gets deployed several times. It could be a branded website or a different deployment with different settings. So we had these large projects, and we're really a big fan of Spring, the entire Spring ecosystem. So they were built 100% on Java and Spring, with your very traditional layered architecture, a data layer, a service layer, business layer, controllers, very, very classic. Of course, when you have larger projects and you have several of those, you start looking to sharing some code, right? So we've been using custom shared, in-house shared libraries for many years, which we deploy to an artifact repository, reuse them and stuff. We've all been doing that. However, we were missing something. We did not have a good way to quite easily share fully functional features. Shared libraries are usually quite technical libraries. They contain utility classes or things like that. But we were really missing like a bit of a common language to be able to like export let's say a user management section and then reuse it in a different application. See, what we wanted to do was we wanted to shift the architecture a little bit from the classical horizontal slicing that we had for many years to a more vertical slicing, where we bundle up functional features into modules. Okay, this is again the word module here I use in a different context than a GDK 9 module or some of the other module types you've been hearing about at Devoxx. But we want to bundle them up in modules, and within a single module you could still find, for example, the traditional layered architecture. Now I don't know if some of you have seen the talk on modular monoliths earlier this week. It's a bit the same idea. This is the shift that we wanted to do. But we were not able to do that very easily. We needed some framework, something that would help us do that with our Spring-based applications. We wanted and needed a way to define these modules. And we had a couple of, let's say, requirements. We wanted them to be more or less pluggable. Okay? So either you put them in the application or you don't. To compare, we used to have big applications with like, if it gets deployed in several different versions, you might have one big code base, and but then you use feature flags to decide, oh, here that's on, there that's on. We wanted to move a little bit away from that and just say in that deployment, we just don't put that module there, and that one we put it there so it comes on. So when it's on, it brings a full set of functionality. Now, to be able to do that, it needs to be able to create its own context. So that's what we consider self-installing, right? You plug it in, it needs to set itself up to be able to do what it needs to do. Important, Spring over the years has actually moved to less and less, let's say what I find at least, overhead configuration. So we really wanted to keep that as limited as possible as well. We wanted more productivity even than we had before. So that's what we needed. That's one of the things we needed, but very important. We looked at the applications projects that we had, and we didn't really have a case for hot pluggability. There was no need for us to be able to, at runtime, update or add a module or something like that. Furthermore, we really wanted to stick as much as possible to the Spring ecosystem. Don't go much beyond that. Don't bring in extra dependencies. Don't change our way of working. Stick to what we used, we're happy with already. Because we wanted to be able to migrate our legacy applications as easily as possible, gradually, step by step. So, when we were thinking about this and we were looking at a way to do this, of course, when you talk about modules, you come into contact with OSGi. So we had a couple of discussions, and is OSGi something for us? But we decided it was not really what we wanted in this case for two reasons. Like I just said, we had and still don't have any real requirement for hot pluggability. Runtime reloading of modules, that was not really something we needed. Plus, it would be a much larger shift away from how we were working, which would make it harder to transform our legacy application. We really didn't want something where we had to say to the customer, okay, 2-3 months and we'll rebuild the entire application to a better way, but in those 2 months it'll be very hard to get new features and stuff like that. That was just not a fit with us. So we came up with our own framework, and we called it Across. I only just realized I need to have a talk with the designer of the logo, but the OS stands for open source. It's not like we built an operating system or anything like that, right? I wouldn't want to get that idea out there. Across is just a base framework that allows us to define these modules and helps it actually defines as well how you can use them. So what we understand on defining a module is you need to define the configuration, right? In Spring, you quickly think of configuration classes or application context XML, stuff like that. The services they provide, but also very importantly, dependencies between modules. Have a way that modules can talk to each other. Services from one can talk to services from the other. And stressing again, what was very important for us, define a light layer on how they can set up their own context, right? Install themselves, migrate between versions if necessary. And of course, quite basic, how they bundle and load basic resources. That's what Across is, and it's entirely built on top of Spring framework. Okay, it started a couple of years ago, before there was actually much Spring Boot around. Nowadays we are migrating more and more to Spring Boot and introducing compatibility there. So I mentioned Spring Boot, but then how is an Across-based application different from a standard Spring Boot application? And it's different in some important ways. To explain that, we need to zoom in a little bit on the Spring application context. Now, your classic, typical Spring Boot application has a single class as a starting point annotated with @Spring-Boot application. What happens when you start the application is an application context gets created. That's the red box over there. And you load all your beans, components, services. They all get instantiated in that application context. That's the blue dots. So basically, simplified, a Spring Boot application is a single application context with everything in it. And that's the most important difference when we look at an Across-based application with different modules. In Across, every module is its own application context. So we created an annotation called across application, pretty much the same way as Spring Boot. It's not like we stole any ideas there. And when you use that one, a parent application context still gets initialized, where you do the configuration of your modules and maybe some utility beans that get used by everyone. But then all the separate modules have their own application context with their own beans, components, services in it. And that's a very important difference. Spring Boot, single application context, cross-based application context, it has like number of modules plus one, at least that many application contexts. The big difference here has to do with bean visibility, or in practice, the ability to auto-wire components. Now, in a Spring Boot application, where there's one application context, all beans inside a context can see each other. They can all access each other, they can all depend on each other, and you can have, like there in the center, you can even have a cyclic dependency. I really wouldn't advise it, but it's possible. When we go to an application context hierarchy, things are a little bit different. On the right screenshot, module 1 has its own application context with several beans in it. So inside module 1, all beans can see each other, they can depend on each other, that's no problem. Now in Spring, an application context can also see all beans of the parent application context. That means module 1 can perfectly well access any beans from the parent application context. Not a problem there. It gets a bit tricky when we try to do this. So I have module 1 with its own application context and module 2 with its own. So they're siblings in the parent application context. Siblings do not know that they exist. So they definitely cannot see beans from each other because they are not aware of each other as application context. So in this example, module 2 is not able to wire bean from module 1. Likewise, at the bottom, a parent application context does not know of its children. So it is not able to see beans, pick up beans from a child application context. So that does not work either. So we had to find a way to allow modules to use services from each other that they provide. To be able to do that, module 1, if module 2 wants to use a bean from module 1 needs to expose that bean. Basically what happens when it exposes a bean is we create some kind of ghost bean definition in the parent application context, and then module 2 is able to see that one and can simply wire the bean. It's not a copy, a clone, it's simply a reference to the actual bean inside the module. So that's how modules can use each other's bean. Important, you need to explicitly define which beans you want to expose. You need to think about your public API of module. At the bottom, we still cannot wire from the parent application context beans from a module. Don't do that. Sometimes it might work, but don't do that. This is also the reason why in the current version we cannot just use Spring Boot auto-configuration. Because what Spring Boot auto-configuration does by default is it puts all its beans in the parent application context. And that would mean that they might interfere or cannot access the beans from the modules. Okay? I'll show you ways to go around that a little bit. So we know this works, but there's another caveat, a second very important part. Let's say module 2 has a bean and it wants to make it available for other modules to use. So it exposes that bean. Then we know module 3 can wire that bean just like any other component. It can depend on it, use it, not a problem. However, module 1 still cannot. And the reason for this is modules are ordered, which makes a lot of sense. You define dependencies between modules. In this case, module 2 depends on module 1, module 3 depends on module 2. The dependencies will determine the order of the modules, and the order will determine the order in which the application contexts get created. We call this the bootstrapping. Okay. Bootstrapping is basically creating the application context of every separate module in the order. But that does mean that if you rely on a bean, well, basically it means you cannot rely on a bean in a module that gets created after your own. Okay. So this is the second important part. You need to think about the dependencies that you define between the modules, because the order is important. So that's how when you think in modules is different than when you just think in terms of a single application context. You need to think a bit more about how you structure your modules, how you determine the beans, the services you want to expose, and put your dependencies right. Okay, enough theory. Let's have a look actually at some code now. So I hope that's a bit readable. I have this sample application, which I'll first start. Okay, as you could already see here, it's basically a Spring Boot based application, but it's an Across application. I'll first show you the result. So it's a simple website. We call it the catalog application, where you have one or more categories. A category has an item has a name and a price. An item can be on sale, and the on sale items are rendered on the homepage. It's a very simple website. In this instance, I can also switch language. It's localized, things like that. So let's have a look at how it's configured. Then you can immediately see how an application based on Across modules differs. So I'll start with the POM XML. Nothing special here. You'll see there's not that much special either way. Perhaps the most important to note here is that we inherit not from a Spring IO BOM, but from our own BOM, which builds on top of Spring IO. In this version, I believe it's the Athens platform release, so we're Spring 4.3, we are Java 8 either way, Spring Boot 1.4, and we add Thymeleaf 3. For the rest, nothing special. I just added all the dependencies I'm going to use throughout this demo already in there, which are these modules. Not many of them are used. And then you do see some of the starters of Spring Boot present. The central starting point, like Spring Boot application. Okay, first off, this code is basically the code of a primer series that we're developing. Some of the articles are already online. I'll refer to them at the last slide. But definitely all the code is there, and it's pretty much explained commit by commit what's happening. So our application here, instead of the Spring Boot application annotation, we have the Across application annotations, and we are using two of what we call the standard modules, AcrossWeb, which basically sets up some Spring MVC stuff, and Hibernate JPA, which sets up a shared entity manager. Below you can see it's just your normal configuration class. It's just Spring. I can import other configuration classes. So I cannot use the full auto configuration of Spring Boot, but if I know what, I can just import the configurations. It's no problem. This class is a Web MVC configure adapter, sets up the local switching. Not very relevant. For the rest, I have some entities. These are plain entities with some validator annotations, and I'm using Spring Data repositories for the entity management. The views that we just saw, basic controllers, nothing special there. So if you look at it, when it comes to the code itself, apart from some base classes that I use, which have nothing to do with Across itself, the only real difference is the packaging. Right? The fact that everything here is in an application package, and I'll explain that in a bit, that actually the terms makes automatically a module. The views, as I said, we're a big fan of Thymeleaf. So there are Thymeleaf templates, and there are some static files, and then there's some message properties. Nothing special there. If you'll notice, I nowhere configured anything of Thymeleaf. I nowhere configured everything of message sources, but it automatically loads. That's one of the things that Across does for you, as I said, bundling of resources. It has a standard way to do that. So when we started this application, here I defined two modules, web module, JPA module. If we look at the output, I hope that's a little bit readable, but basically what it says here is bootstrapping 3 modules in the following order: Hibernate, web module, and catalog application module. Again, this is important output, it stresses the order. So you define dependencies, there you will see what the resulting order of the dependencies was. Important here is I nowhere define the catalog application module. This was created automatically based on the package. And the reason for this is, like I said before, if we put our business code in the parent application context, it might be harder to work with modules. So we put it even inside a single application, it gets shifted inside some dynamic module. So when I started up this application, I have the entities and a database got created. So I added H2 console, okay, with a physical database. So a simple database got created with a database schema, where my default categories are in, and then some tables of across modules. So how did these get created? Well, this was done through installer classes. Now I have 2 installers in my project here, in my module, a schema installer and a test data installer. Installers are special beans, so to speak. This is the schema installer. As you can see, it inherits from a liquid-based installer. So what it basically does is it runs a liquid-based schema file. Simple. And this is the test data installer. It's annotated again with an installer annotation. And the only difference is it uses the repositories to create my test data. And also, it only executes if the dev profile is active. Maybe you noticed, but my installer annotation has a couple of extra values. One is version, and one is phase. Now, the phase here, they have a different phase. The schema installer has a phase before context bootstrap, meaning I want this to be executed as early as possible. Before any of the modules start, I want my schema to be modified. The test data installer says, I want to be able to use the beans from the module. So I need to execute once the module is available. Now, installers, you could say, we've been doing this, and we used to do this as well. Why not do this with a regular add component and an autowired method or a post construct method? Why do you need to have a special annotation, a special location, and annotate the methods you want to execute in a different way? Well, there's a reason for that. It's because installers are a little bit special, right? And they are one of the more important features that we found when it comes to building self-installing modules. So what's the difference? Installer beans are only created and called if they need executing. And once they're done, they're destroyed. But they're destroyed in such a way that the only thing that will remain basically is the class that has been loaded in the class loader. There will not be any bean, there will not even be a bean definition visible anymore. To determine if they need executing, installers are versioned and tracked. Versioning is optional, but as you saw on the annotation, I can specify a version number. So what happens is AcrossCore will check which installers does your module define, which versions do they have. It will check in its local repository what are the last installed versions. Is it higher? Okay, I will execute you. If it's not higher, I won't do a thing. To do that, current implementation needs a single database. So it works on a central database to track, SQL database to track its installers, which is still a very common use case in a lot of web applications. Furthermore, it uses that same database to perform synchronization. Every installer is synchronized. So if you have, like, again, a very common use case still, if you have a website which uses the same database backend, but you have multiple web servers you deploy it to, and you deploy them simultaneously, you do not want your code to execute 2 times a migration, for example. So that's what the distributed locking mechanism takes care of. You might notice from something like Liquibase, only this applies it to any kind of installer. And it's this mechanism that has eventually allowed us to evolve from doing sometimes still a manual migration, when, for example, Liquibase scripts were not enough, to doing everything through installer beans. Basically, we can add them. They will get executed if they need to get executed, and if it's not like a common reusable module, after a while we can just throw them away because they are not relevant anymore. Last thing, as I said, they are bound to a certain phase of the Bootstrap, which will determine if they can use certain beans or not. I'll go over this quickly. I left this in just to for when I published the speaker deck. So, installers, very important concept for general module, but I still have plenty of time, so I'd like to illustrate a bit how modules can work and play together. Okay, so throughout the years, we've encountered some. We noticed that we had a lot of common code and modules that we actually used throughout many projects. So we decided to gradually just make these generally available. We call these the standard modules. So let's. I want to show you a bit. How using some modules can impact your productivity as well with an application. So I'm going to add a debug web module. Okay, I'll just recompile the code. Spring DevTools is active, so the application automatically restarted. Installers did not get executed because they were already there. Okay. So now I have my application, and on debug I now have a whole set of debug development pages. We use debug web to actually inspect the across context, because otherwise it's not that easy to inspect the hierarchy of application contexts. So here I can see that's a bit like the logging output. I see the order of the modules, and then I can jump to a single module and see which beans they have, which beans they expose as services to others. So debug web is an example. I just plugged that in. I mean, I had the dependency already. I just activate it, and we get a whole web interface. Another example of how you can play with that is, I'll add a module in a different way, because a module itself can be defined as just a bean in the parent application context. Okay. And I'll add, this is a logging module, which will give us some more information on the logging settings. Yeah, let's enable that just to show. Okay, recompile. Don't need to do anything. Application will restart. Okay, done. So that's Spring Boot DevTools. I love that. Going back, now we see that the logging module got added, and it got added high up. That's because of some dependency rules that it it defines. And if you pay attention, you see that now we also have an extra menu here. Okay? Because logging module, in this case, these modules, they know of each other. They play well together. Logging module knows, sees that debug web is there, and it has added a logger page where you can at runtime change the log levels. And useful for debugging, we also have an option to enable the full request response log that comes in, which can be pretty useful if you have like REST web services. It actually shows you the full body that came in and the full request that went out. But debug web and logging that I just showed you, they're still more technical modules, right? They aid us in development process. I'm just going to put this one at false. But throughout the years, we've also built some modules that help us, as I said, with more functionality that we wanted to share. So let's say that I want to have a management interface for my catalog and category. So I'm going to add a couple of modules. I'll explain a little bit. On the way. Yep. Recompiling. And now it's taking a bit longer, and if you were fast enough, you see that we have Liquibase executing all kinds of things. This is for the user module. Let's first go and have another look at our context browser. And now I see there's a whole lot more in there. I added 3 modules, but actually more were added. This is how dependencies, explicit dependencies, can influence your across applications. If, let's say, the user module has a required dependency on the properties module you see there. So what happens is across, in this case, knows where to find that module, and it's available on the class path. It just pulls it in as well, and again, the order is influenced and determined, right? So the dependencies can work. So a lot more modules got added transitively, and if I now go back to the database, I can see there's a whole lot of extra tables added as well. This is an example, in this case user module, which is more like a general purpose user domain. Comes with its own installers, it installs its tables, we prefix them with UM to really show, don't touch these, they're the responsibility of the user module. But we didn't have to do anything for that. Of course, if you remove user module, they will not be removed, right? They'll stay in the database. So let's see what I added now. If I go to admin, I now get a new user interface. This is the admin web module in action, just provides you with a very light, general administration UI framework, so to speak. It sets up like a base controller, a secured path. It integrates Spring Security. And yeah, basically that's pretty much it. I can log in with admin, but that user that I'm logging in with, that's not the admin web module. That's the user module. So, because they play well together. If by default, admin web module is there, user module detects it, builds its user module, sets up a Spring Security user detail service, so I can log in. This is the administration section, and I notice that I get a section entity management. That's what the entity module gave me. So user module, which I added, provides a general purpose user domain. So you get like a user with one default created, where a user can have a role. A role consists of permissions. Users can be managed in groups and things like that. It integrates with the Spring Security model. So it's something we use for simple applications where we don't need a custom, much custom security things. We just plug it in there and we get pretty decent features when it comes to security and user management. But perhaps more interestingly is we can now also manage our category. Let's say I create a new category here. Right, and then an item, car, with a price. I'm not going to go into too much detail here because if you're more interested in these modules, the actual primer does give a step-by-step more information. So I can easily add a category, and I didn't have to do a single, right, it's on admin, have to do anything. I just dropped in the entity module. Because in this case, what the entity module does, it's something that we designed. We noticed we have a lot of applications with entities, but there's no real requirement for a backend management interface, at least not from the customer side. So what happens is we don't build one. And then we always end up, fussing about with in database when we want to manually check something or that not. Right? We said, okay, we want like a general purpose module. We plug it in. It helps us. It generates user interface based on Spring data repositories, and it tries to do so as intelligently as possible. And that helps us have a UI to manage entities, but without having lots and lots of generated code in the project for those admin controllers, because they're not really that important. If you're into like this code type thing, generated and stuff, you should really check out JHipster, for example. They do great work on that. But of course, let me show you, I can customize it quite a bit. And this is important, what the entity module does, for example, compared to Vaadin, we really built something that was useful for us. We like custom web applications, meaning we work a lot with Thymeleaf, a lot with JQuery, Bootstrap, especially backend. So we needed a solution where we could easily plug in like a Thymeleaf template instead of a certain control. So that's possible with this. So just to show a little example of customization, let's say I have the category view here, and it's sortable, okay, but there's no default sorting. So let's say I want this list to be by default sorted by name, and I want to show also the number of items. So luckily, entity module does have an extension point for that. Right. Let's be category. So I select the list view, and on the list view, I want the default sort to be done on name, and I want properties in order, name, path, and item count. Now, there is no property item count, so I'll just make a fake property, give it a display name, and use it, get it through a spell, which would be items.size. Right. Oh, no, there we go. So now the list view is sorted, items added. So for, well, I'd say simple, but you can do some pretty decent stuff with that. We use that for custom views. We switch to a different approach. Maybe that's, I have plenty of time, so what I'll do here is I'll check out to one later branch. Oh. That adds, again, all in the primer. This one adds some security and a custom controller for the administration interface. So if I refresh now, well, you already saw a security error there. Okay. Wait, I will log in. So what's happened now? Oh, I lost the catalog section. The reason is the role has been updated. Something, apparently I might have not switched to the right brand. Okay, anyway, I guess I won't spend too much time on this, but this does show, for example, here I have a totally custom controller that plugs into our admin interface. This controller is your completely normal Spring controller, with the only exception being that it is an admin web controller. And the reason for this is that we wanted to make the path of where admin web is customizable. So I know what I didn't do. I didn't rebuild, I think. Okay. So if I rebuild now and restart the application, it should no longer be available under /admin, but it should actually be available under /secure. No, we might have to do a physical restart. That must be DevTools letting me down. There we go. Ah, that's better. So this is a way of how, now it runs the new installer installing test users. So that's something we do. For example, we have installers that install a custom permission. And then we have separate installers that install test users. Again, this one would be linked to the dev profile to install users with a certain role. Now, this is an example of what we call the standard modules that we've all open sourced, but it's just an illustration of how, if you think modules through and design them well, how well they can play together. But now I have plenty of time, so I want to show a bit how easy it is to go from our application to creating a separate module. Because so far we've only had our application built on top of modules. So let's see about checking out a new branch here. Wait, IntelliJ often doesn't like when I do this. So. See, cannot load two modules. Okay, hopefully this will work. So, yeah. So in my project now, I got two new modules that got added, which are now my applications. If you recall the previous view, I had a catalog application which defined the single application. That's no longer the case. Here was the catalog application, but that has now been replaced by, instead of catalog application, I put a class there called catalog application module, and that's now a module descriptor. That's the only thing I actually changed in this case. Okay? Instead of an application, I put a descriptor with the same name. A module needs to have a unique name and a separate resources key. This is the reason why, if you looked at it, the paths of the resources, both the messages, the templates, may seem a bit odd, right? They might seem a bit convoluted. The reason for this is they need to be unique, guaranteed unique per module, because we do not want any conflicts when we serve static resources or fetch templates or stuff like that. We're still working on simplifying those, but once you know what they are, it's pretty easy. So this module descriptor defines a name, defines a resources key, defines a default component scan for when it gets for its own beans, and then it defines dependencies to other modules. That's it. That's all I replaced in our original project. And then I created a separate application project where I moved the two test data installers to, because obviously test data installers are usually not the scope of the standalone module, but often the scope of the application itself, right? So I moved those two test data installers that were originally in my project. And then I created a new application class. The application class, this one, brings in admin web module, entity module, user module, and manually creates the catalog application module. However, I no longer, in our original application, we pulled in AcrossWebModule and JPA module, which helps us with controllers and a shared entity manager. That's no longer necessary, and the reason is I have them as required dependencies specified on my module. So it knows it will, like Maven pulls and stuff, it will pull them in. So if I run this application, which will hopefully work, right? I should pretty much get what I got before. Same layout, admin management, etc. Apparently I have a demo. Okay. Yeah. Only I started without dev mode, so the test data installers didn't run. So let's see if my admin section, yeah, it's available under private in this application. Yeah, so this brings in some extra, but you know, I got the management interface. I basically got everything that I got before, only now I'm making use of a separate module, and I moved the installers inside my own. So to illustrate the point a little bit further of what you can do, I created a second application. Again, the application package will contain the application-specific code, right? So the second application, which is an other sample application, is a bit simpler. So it doesn't bring in any other modules. It does not bring in admin web, entity module, user module, none of those. It does bring in catalog, application module, and it doesn't allow language changing. It just fixes the language to Dutch. Because I don't bring in, let's say the use case here is it's a fixed website with fixed data, and the data cannot be managed, it just comes from some other process. I don't have the administration module added here, so if I want data in there, I need to install it. So I created a separate installer that just fixed installs the data in the application. And then lastly, I didn't go into that, more in the primer, I decided to customize the menu that the default catalog creates. And also I switched the default template to show you my extremely well design skills. So let's run the other sample application, which should be on port 8081, so it can run. Okay. There you go. Same module. All we changed here is the base layout. The products got inserted through the installer, but there's no sign of any admin module or entity module, simply because all the beans have been declared either as optional depending on the presence of module, or just using regular Spring Boot conditions. That's also perfectly possible. So if we compare the two contexts, this one doesn't even have debug web, but you can see here that this one's much simpler, does not contain all those modules. Yet it's exactly the same base module that we used. All we need to do was take care of thinking about how dependencies are. And how they integrate. So perhaps relevant to know, regular Spring Boot does live reloading of templates and message sources and stuff. We do that too. Right, already shown you when I enable dev mode. Let me, of course, in a multi-application setup, so man wants to show something and then yeah, now it should work. And if it doesn't work, I'll stop trying. Okay, so that and that's the same thing if you follow the conventions of where stuff is, where you put your resources. That will work for Thymeleaf template for the message sources and stuff like that. You don't need to configure anything for that. And that's across. I showed you a lot of the things with debug web, admin web. I mean, perfectly usable, but that's not across core. Those are like the standard set of modules. We have some different projects which use completely different set of modules, and that works just fine. The important thing for us was, and still is, we're basically working with Spring application contexts. We just need to think a little bit more of our public API, how we separate things, but the framework gives us a nice way to easily define dependencies, set up stuff, run things like the installers. So, let's see. Yeah, I'll leave these in, but I pretty much explained most of them. Debug web, we saw. Logging module, add some logging infrastructure. Admin web, we saw as well. Hooks into Spring Security. User module gives you a user domain model. So I added the three together, right? But you can perfectly well add them separately. If you just add admin web, you don't get users. You'll have to do the authentication yourself. If you do just user module, then you just get the user domain module, services and stuff like that, but no user management. So there's really no need to add them together. I just wanted to illustrate how well things can play together. Okay, entity module. There's some more. By the way, especially related to user module, we have one building the OAuth system where you can manage your clients through the admin interface. We have one hooking up with Spring Security ACL, building database model, hooking in with user module. LDAP for syncing things from Active Directory. They're on our website. If you're interested, you can. They're all open source, totally free to use, so you can just check them out. I think I hoped I have illustrated how easy it is. It's really just determining a module descriptor, and that's about it. So I really hope I gave you some context on the framework. It has helped us a lot throughout the years in actually modularizing our more larger Spring-based applications. We're working hard to make it even integrate better with Spring Boot and Spring Boot starters nowadays. But I hope I've shown you an example of how well-designed modules can play together nicely, and also how easy it can be to migrate from like module-based application, which was not a lot of code, to a separate module. So if you're interested, across.foreach.be is the starting point. From there, you will find all the links to the source code, the issue tracker, the different modules, the reference documentations. All code that I've shown here is from the primer series. The code is all available with commit by commit. We hope to have put a simple enough explanation telling what happened, so there are small changes. The articles are still a work in progress. Only part 1 is published, and part 2 will be next week. The reference documentation for everything is available on the docs path, and all source code is in Bitbucket. If you have any questions, you can Stack Overflow, use the label across, we'll be monitoring that, or you can just tweet me directly. That's it. If you're very interested, thank you. If there anybody has any questions now still, feel free, or just come on down. That's, no? Thank you. That was DevOps 2016. Thanks.